General applications in two unknowns. The sum of two numbers is 55 and the difference between them is 23. Find the two numbers. We're asked to find the two numbers, so we're going to use that as our cue to define our variables. Let x and y be the two numbers. And since we have two variables, we're going to need two equations in order to get a solution. First equation will come from this statement here, the sum of the numbers is 55, and the second equation will come from this statement here, the difference between them is 23. So that gives us the sum is 55, x plus y is 55, and the difference is 23. That gives us the equation x minus y is equal to 23. Sometimes we have to be careful about the order in which we subtract because subtraction is not commutative, but I can tell from my first equation that it doesn't matter which of those was x and which of those was y, so there's not been any sort of variable declaration here that would make it important for me to subtract x minus y versus y minus x. I'm going to choose to solve this system of equations by elimination because I think it's easiest. The y variables are all set to drop out when we add the equations together. That gives us x plus x is 2x, and 55 plus 23 is 78. Dividing both sides by 2 gives me x equals 39. And I can find y either by formally substituting into one of these equations, like the first one, x plus y equals 55, or by just going back to the verbiage of the problem, and given that the sum of the two numbers is 55, maybe I could just figure out that subtracting 39 from 55 would give me the value of y. In any case, I'll do this by a formal substitution, which means I'll plug in 39 for x, giving me 39 plus y equals 55, and then subtract 39 from both sides to get y is equal to 16. Now, I want to answer this question in the same sort of language in which it was asked. I was asked to find the two numbers, so I don't want to use x and y in my answer. I want to answer this using verbal sort of communication instead, like to say the two numbers are 39 and 16. There's no units to be concerned about here because these numbers don't actually represent any physical quantity. Going on to the next example, a cell phone company charges a flat monthly rate and a usage rate, and we have two different people using their phones. Gavin used his phone for 381 minutes and had a monthly bill of $115.20. Dwayne used his phone for 240 minutes and had a monthly bill of $79.95. Again, when we come to the end of the word problem where these questions are phrased, this tells us what to let our variables represent. Let's let x be the flat rate and let y be the usage rate. The usage rate is the rate that gets multiplied by the number of minutes. So let's make an equation out of Gavin. Gavin used his phone for 381 minutes and had a monthly bill of $115.20. So looking at Gavin, we would calculate his bill by taking the flat rate, x, and adding the usage rate, y, times the number of minutes. And this would get us his total bill of $115.20. Realize how important it is to have defined our variables for a problem like this. It's very common for students to try to skip that step, but it becomes really hard to figure out exactly how our equation gets phrased without knowing that x is the flat rate and y is the usage rate. So the reason that this works is because the usage rate is dollars per minute and 381 is the number of minutes. So if I multiply minutes by dollars per minute, then I'm going to get dollars, and I'm going to get the dollar amount that was charged from using the phone. Now we'll make another equation from Duane. His bill is again the flat rate plus the number of minutes, which in this case is 240, times the usage rate y, and his bill is $79.95. So we now have two equations and two unknowns, and we can solve this system of equations to find the flat rate and the usage rate. I'm going to rewrite them so that we can get ready to use the elimination method. Okay, so we have this system of equations. We don't have to think about where it came from while we're trying to solve it. I would choose to target the x variable, which means I'm going to multiply one of these equations by -1 to make that coefficient negative. I'm going to choose the second equation just because I can tell that I'm going to get a positive coefficient of y that way. So the first equation will stay x plus 381y equals 115.20. Make that one a little bigger. And the second equation becomes minus x minus 240y equals negative 79.95. When I add these together, the x's drop out as designed. The y's combine to get me 141y. And on the right-hand side, I get 35.25. Dividing both sides by 141, this is a good time to bring in the calculator. I get 35.25 divided by 141 equals 0.25. So my y is equal to 0.25. Now I'm going to substitute that back in order to find x. Taking either of these original equations, I'm going to choose the second one. X plus 240 times y, which we now know to be 0.25, equals 79.95. And of course that 0.25 came from here. Now I can multiply 240 times 0.25 is 60 because it's like taking a quarter. 79.95. When I subtract 60 from both sides over here on the right, I'm going to write that as 60.00 to get x equals 19.95. So I have x equals 19.95, y equals 0.25. I need to refer again to my variable definition to know what units to express these with and what they are. So x is the flat rate, so it looks like the flat rate is $19.95, and y is the usage rate, so it looks like my usage rate is 25 cents per minute. And this would be my final answer. It's very important to make sure that we answer the question completely using both values with units and labels. The units in this case were dollars and dollars per minute, and the labels were flat rate and usage rate.